Hello. Okay. And good morning to all of my students. Okay. So we're going to discuss about the exercise I given in the WhatsApp group. So there are 5 questions, and it's all about a scalar and vector. Okay. So we're going to look at the first question in the exercise. So the question number one is a diagram that shows two forces acting on the box. So there are two forces, 60 Newton and 80 Newton. So 60 going up and 80 going to horizontal to the ground. Then what is the resultant force acting on the box? Okay. So we going as in physics we have to draw. Okay. If you cannot draw, you can find you will not uh, see actually the details surrounding the object or the force that acting the object. So the forces that acting the object is in this way. So we have a 60 over here Newton, and we have a 80 going this way. Okay, and 60 degrees over here, right? 60 degrees in this that is 60 degrees to the horizontal. Okay, so it's either you want to use my step. There are two working actually, two method. Either you want to resolve all this component into x and y. I mean that, let's say we name it f1. This is f2. You resolve into f2 x and f2 y, and this is f1 x and f1 y, and then you have the tables. Okay, you draw the tables, and this is x, this is y, and then this is f1, this is f2, and this is f resultant. Okay, and then you plus or minus, and then you get the answer. Okay, and then you get back uh the net by using Pythagoras theorem. F resultant equals to x square plus y square, and then also you can find the angle by using tangent theta equals to y over x. Okay, this is one of the method that I told you to you can use it by you can find the answer by using it. One more is by using sine and cosine rule. So sine cosine rule is also can be used if you remember the sine and cosine rule in at max. Okay, it can be used on the triangle. Okay, how to use a cosine rule in this kind of question? So as we see, you can have 60 Newton and 80 Newton over here, and the F, as we know, the F should be going in this way, right? The F using a parallelogram method, you know that the resultant force is going in a diagonal line like this. Okay, so a parallelogram, you know that there will be this line should have the same as parallel to this line. Of course, the drawing is not perfect. And one more, this one, this line should be equals to parallel to this line. Okay, so what we can do, okay, so 60. Now we want to find what is the angle over here. Of course, the f to the angle, uh the the resultant force to the angle of to the horizontal. Okay, and over here we know that it has 120 degrees, 120 degrees angle. Okay, so I'm going to draw back a new diagram. Okay, so this is the F. This one will be the angle. Okay, the angle. And this is 120 degrees. And again, this is 80 Newton. And this one will be 60 Newton. Okay. Okay, so this one on top will be 60 degrees. Okay. So remember in the cosine rule, what's the law of a cosine rule is you have A, B, C, A. So A squared equals to B squared plus C squared minus 2 A B cos A. Right. So AB cos A. 2AB cos A, correct. Okay. So we can apply this cosine rule. So we can find F. So F squared is equal to 60 squared, okay, plus 80 squared and minus 2 and times with 60 times with 80 and cos 120 degrees. Okay, so you can find that the F is equals to 1 to 1.7 Newton. Okay, so the resultant force over here, the magnitude of resultant force is 1 to 1.7 Newton. Now we want to find how much the angle. Okay, angle we can use a sine rule. If we remember sine rule, we have an angle uh, A, B, B, and C, C. Sine A over A equals to sine B over B equals to sine C over C. Okay. So in this diagram, we have actually sine theta, this one is equal over 60 is equals to sine 120 divided by 1 to 1.7. Okay, this 1 to 1 came from the answer over here. This one, okay, came from here. So this is 1 to 1.7. Okay, and we can get the sine. We can get the sine theta equals to sine 120 times 60 divided by 1 to 1.7. So theta is 25.3 degrees above horizontal. Okay, so answer is, for this question is, first one is 1 to 1.7 Newton and it is 25.3 degrees above the horizontal. Okay, so that will be the answer for question number 1. Next, question number 2. A car travels with velocity of 12 meters per second due to north on the straight road, then travel to the west with a velocity of 16 meters per second. Find the change in the velocity of the car. Okay, so what we have here is a car that is going to the north. Okay, it is going to the north, straight going to the north, and then it goes to west. Okay, so it was going with a 12 meter per second, and then it goes to west with 16 meter per second. Okay, I want to label out, this is U and this is V. Okay, when we says about a change of velocity of the car, you have to remind yourself change of V is v minus u. Okay, take account to this one. This is very important. You are saying about negative u. Okay, negative u. So this u has to be flipped. Remember when we learn in vector, when you have negative u, the u must be flipped. And because the u is pointing up, we can use this u, the same vector. What? Cannot. Okay, now it cannot be. Okay, this is the u. You can see that both u having the same length, but the direction is different. One is pointing up, one is pointing down. Okay, so now I'm going to label this is negative u. Okay, and the change of the velocity is from the u v to u. So it is here is a triangle that we want to find. This is 90 degrees. So this is v minus u. Okay. So change of to get the change of v, that this is one, the change of v. You have 16, you have 12. So change of v, theorem Pythagoras squared is equals to 12, okay, plus 16 squared. So this one will be 20 meter per second. So the magnitude of the change, okay, is 20 meter per second. Now we want to find the angle. Okay, the angle is between u and v. Okay, so this is very some student is confused which angle, this one or this one. Okay, so we are talking about u to v. You can see that this is u. The angle over here is coming up from this point to this point. Okay, so we are going to use this angle, not this one. Okay, so u to v, this angle, and this angle, okay, is tangent theta equals to 16 divided by 12. That is 53 point, angle is 53.1 degrees. Okay, so because it answer is in a vector, we have to give out the magnitude and direction, both of them. So the change of velocity of the car is 20 meter per second with the south of 53 degrees west. Okay, because we are not we are using the angle that is not related to the horizontal. Okay, and then we have actually the direction of the west and the south. Okay, we can use the south 53 west. Okay, next one, question number 3 is shows a horizontal force F pushing a block of a inclined plane. If the weight of the block is W, okay, what's the net force acting on the block parallel to the inclined plane? Okay, so this one we have to do two, we call as an free object diagram. One is a block, so this is inclined plane, this is a block. Okay, so the mass of the block is pushing downwards directly, so we call it as W. Okay, and because we have a normal reaction force, okay, so it is a normal force, so it's pushing downwards, actually going up. Okay, so this is a break W cause actually the normal force pushing upwards. Normal going up, so it was balanced by W cos theta. If you have only normal force, the block should be flying, right? Floating above, because it doesn't have any counterbalance to pull back the block to the inclined plane. So W cos theta is the one who pull back the normal force. So and then we have over here is the by the wake. Also, you are going to slide, of course, is W sine theta. Where is the theta? Theta is over here actually. Okay. So W cos theta pointing downwards, and W sine theta is pointing left. Okay. So the where sometimes students do ask me where is the 90 degrees. 90 degrees is over here. This is 90 degrees. Okay. So cos theta putting downward, sin theta pushing left. And we also want to draw a free body diagram for the F. So the F is here. It's easier to put here. So F, and we have this as the angle. So angle should be same. So this is F cos theta going this way, and F sin theta in going downwards. Okay. So what will be the net force? Okay, the net force, you can see that will be these two forces. That is W sin theta, that is pushing downwards by the block, and F cos theta, that is the one that's pushing upwards. Okay, others will be cancelled out by other forces. So answer is net force is equals to F cos theta minus with W sin theta. Okay. Next question. Question number 4. The diagram shows three coplanar forces acting on object. Calculate the total vertical force, total horizontal force, and the resultant force. Okay, so this one you can use the table method, the one I told you that I want to taught you before. Okay, so we're going to resolve every forces. Okay, so for this one I rename as F1, this is I rename as F2, this one I rename as F3. Okay, and 50 Newton over here. Okay, to the Y of 50 Newton you have 50 sine 40. This is 50 cos 40. For this, for the 60 Newton, this one will be 60 cos 27. This one will be 60 sine 27, and 40 Newton to the left. Okay, it doesn't have any y, it's only have fx. So this one only fx to the left. Okay, now A, total vertical force, okay, means that up and down only happens in the y direction. So we have 50 sine 40, okay, plus with negative. Okay, I hope you know why it's negative. Sine 27 degrees. Okay, and is equals to 4.9 Newton. B, a total horizontal force is equals to 50 cos 40 degrees plus 60 cos 27 degrees and minus 40 because in F3 is pushing to the left negative. So it will be 51.8 Newton. Okay, so now the resultant force, you can use Pythagoras theorem. Okay, F equals to square root of 4.9 squared plus 1.8 square equals to 52.0 Newton, and tangent theta is equals to 4.9 is y over x, 51.8. Okay, so it is theta equals to 5.4 degrees above horizontal. Okay, so resultant force is 52.0 Newton, this one, and with 5.4 degrees to the horizontal. Okay, so that will be the answer. Okay, so going to last question, question number 5. Okay, diagram show two tugs pulling a boat in a river along the direction due to the north. Find the total vertical force acting on the boat. Okay, as usual, we're going to resolve all the forces. This is F1, this is F2. F1 in the y direction, this one will be 300 cos 15. This one will be 180 cos 30. Okay, in the y direction, in the x direction, this one will be 180 sine 30 degrees. This one will be 300 sine 50 degrees. Okay, so now we're going to answer the question A. Total vertical force. Total vertical force is only up and down. So 180 cos 30 degrees plus 300 cos 15 degrees. So it will be 445.7 Newton. And the B, 5 additional force needed to apply to the boat so the boat continues to move in direction due to north. Okay, if you see that this one, the boat is not going straight up. Oh, sorry. This is okay. The boat is actually not going as a straight up like this. Okay, it will be going left and right because those two rope, okay, two tugs that pulling has their own the sum of them, the sum of the F1 F2 is pushing a little bit left and a little bit right. Okay, so we want to find what is the horizontal force first, then we can determine how to counter the horizontal force by the F1 and F2. So total horizontal force okay is 180 sine 30 degrees plus negative, y negative pushing to the left, 300 sine 15 degrees. So it is 12.35 Newton. It means that if you check the diagram, as the tux is pulling the boat, it will be going to the left, a little bit to the left by 12.35. This way, this way, 12.35 Newton. So if you have a rope, another rope, you can pull it back here with 12.35 Newton, right? So what you do is, you can say that additional force of 12.35 Newton applied due to west is needed. Okay, so you have a rope, you tie at this point and you pull to the west with 12.35 Newton, and then the boat will be continues to move in the straight line due to north. Okay, so that will be the discussion uh, on the question that I gave about scalar and vector. Okay, if you have any question, you can ask in the WhatsApp group, or you can direct message me, DM me in the WhatsApp group. In the WhatsApp also, you can do that. Okay, so see you in next week. Okay, bye bye.